Let's now do problem 28 from chapter 5. So I'll just denote that by 5.28. Let me read it to you from the textbook if you don't have your textbook around. Your costs have been forecast as having an average of $138,000 with a standard deviation of $35,000. Okay, so presumably we have a bunch of costs since this is an average. So we have a bunch of individual costs, and then if we average these costs, the average is like 138. So let's say that let x equal one of these costs that are getting averaged. So and we're told that the mean of x is equal to, I'm going to write this in thousands, so 138, and then we'll put this in $K. All right, and then as long as we're consistent in our units, that's fine. So then our standard deviation is going to be $35,000, so $K. Let's read on. You have just learned that the suppliers are raising your prices by 4% across the board. Find the new average and standard deviation of your costs. All right, so for every item that I am buying, it looks like the cost is going to go up by 4%. So let y equal the new costs. And this is going to be 4% increase. So to get a 4% increase, we're going to take 1.04 times x. And then if you want, you can say plus 0, but that's not really necessary. So that represents a 4% increase. So the problem asks, what are the new average and standard deviation of your costs? Well, the new average, mu sub y, according to our rescaling theorem, is just we have to put the old mean, so mu sub x, through the same linear transformation times 1.04, there's a point there, plus 0. And so what is that? Well, 1.04 times 138 is equal to 143.52. What happens to our standard deviation? So the standard deviation of the costs equal 1.04 times the old standard deviation. So the old standard deviation is 35. We'll just put that in parentheses here. And so the new standard deviation is $36,400. And that's all there is to it. Let's go on to problem 29 now. So 29 reads, for the previous problem, compare the coefficient of variation before and after. Why does it change or not change in this way? So 5.29, the coefficient of variation of x, let's find that out. So remember what coefficient of variation says. It's the relative variation. It's the variation relative to the mean. So it's sigma sub x over mu sub x. And so this is equal to 35 divided by 138. And this is about 25%. So approximately 25%. So it's usually expressed as a percent. What's the coefficient of variation of y? Well, this coefficient of variation of y is going to be 36.4 divided by 143.52, and that's about 25%. Right, so the coefficient of variation doesn't change. If you think about what we just did, that should make total sense. So where did 36.4 come from? Well, it was 1.04 times the old standard deviation, which was 35. Where did 143 come from? Well, it was 1.04 times the old mean, which is 138. And so note the multiplicative constants go away, and you're just left with 35 over 138, which is exactly what the coefficient of variation of x was. So that's just CVX. So let's step back and interpret this. What this is saying is the absolute dispersion of your costs has increased. So there's more heterogeneity now that the price is higher, yet relative to the mean, the dispersion is constant. The dispersion is unchanged from what it was before relative to the mean. Let's do two more problems. The next one I want to do is 30. So let me read 30 to you. You are the sales manager for some regional division of a beverage company. The sales goals for your representatives, so we have a bunch of representatives who work for us, have an average of 768,000 with a standard deviation of 240,000. So why don't we, I guess we'll just leave it on the same page. 5.30. Let's say that X is equal to the sales goal of a rep, so 1 rep. Now we know that mu sub X is equal to 768, and again this is $K, and the standard deviation is 240 $K. Now, let's read on. You have been instructed to raise the goal of each representative by $85,000. What happens to the standard deviation? Well, let's find the mean as well. So let Y equal the new sales goal of an individual. And so we need an algebraic expression that relates the old to the new. Well, we're going to take the old and then we're going to add 85,000 to it to get to the new. All right, so let's see, what happens to the mean of Y? Well, the mean of Y is just going to be the mean of X, 768 plus 85. And I think that's 853. All right, so what's happened? The sales goals of everybody have just been pushed up. What happens to the standard deviation of Y? Well, the standard deviation of Y is going to be the multiplicative constant. Now, really, the multiplicative constant here is 1. 1x plus 85. So we're going to take 1 times the old standard deviation, which is the old standard deviation. So the standard deviation has not changed. If you think about it, that ought to make some sense. So let me just draw a little picture for you. If this is the distribution of the sales goals of the old sales goals, so this was, what, 768? What did we do? Well, we just added 85 to every value. So it's like we picked up this distribution and pushed it out 85. So here's 853, but the dispersion really hasn't changed at all, because we just picked up this thing and moved it out, shifted it out 85, so the dispersion hasn't changed at all. Let's do one more problem, which is 5.31. So 5.31 reads, for the preceding problem, compare the coefficient of variation before and after the sales goal adjustment. Why does it change or not? Okay, so the coefficient of variation of X is going to be 240 divided by 768. And this is about 31%. The coefficient of variation of Y, on the other hand, is going to be 240, so the numerator doesn't change. The denominator, however, is getting smaller. Or sorry, the denominator is getting larger, which means the coefficient of variation is getting smaller, and that's about 28%. So the relative variation has actually gone down by increasing this. Kind of an analogous situation is if if you made $10,000 a year and I gave you a $5,000 a year raise, I just added $5,000 to your salary, that'd be a pretty big deal. You know, that's a 50% increase on your salary. Whereas if you were making, you were a hedge fund manager making $10 million a year, and I give you a $5,000 raise, that means nothing to you. That's pocket change. So it's kind of the same deal that relative to that base, you know, the dispersion has actually decreased. So those are some good examples of the use of this rescaling formula. On the next page, there are some additional problems with solutions, and I encourage you to go through those on your own.